I think you can complete the post-lab while you're in the class on Wednesday. So allow me to clarify that you need this minus materials, like equation plus procedure for the pre-lab. But if you also tack on the data analysis, you will get a head start on the post-lab while you're sitting in the room. Question?
Can you just do it on the back too?
That's probably a very good idea, yes. Anybody else? The tagging lab is kind of neat. There's this strange thing that scientists do. In order to count how many tuna are in the ocean, we staple something to their fins and then we put them back in the ocean. And it's kind of rad that based on that, we know how many there are. Yeah. I can show you when you do this lab. It's a surprisingly simple concept, but none of us ever thinks about it. When you do this, you'll be like, oh yeah, that's a really good idea. So it'll be one of the easiest labs of the year, and it's kind of a cool built-in aha moment for you. Not aha like Math Academy aha, but I mean like, oh, I get it, kind of aha moment. I wish you still had aha too. Now please look up, because the Species Diversity Lab, for some of you, might be a little intimidating. I hear the butterflies in some of your stomachs. I got to tell you a couple of things before we talk about this lab. I don't know whose fault it is. I don't know if you blame the president, or your educational system, or me. But somehow, there is this persistent, nagging misconception about humans. Just so that we are clear, you can quote me on this if you want. Everybody can do math. Some people say like, oh, you're not the right brain type, or it's not the right personality. Horseradish. Everybody can do math. I see it so much in my education, so often, and even in the education of my children, dang it, that some people are misled to believe that perhaps there's something about them which makes them less apt for mathematics. And I'm not buying. There was like a really well-known study about this a few years ago. Somebody wants to look that up. Oh, shows up. But everybody can do math. And so, when I write this on the floor, it's not this low. It's a whiteboard. In my cousin, we don't have whiteboard, it's computer. When I write this on the whiteboard, I see it in your faces. Some of you go, uh-huh. And some of you go, but it's okay. We're going to do this together. I'll walk you through it. You'll probably be writing quite a bit on your Species Diversity Lab handout. Sure. So first of all, there are two different schools. One of them is 97% white, 1% brown, 1% black, 1% yellow. The other one is 25, 25, 25, 25. Which of these has more diversity of desk colors?
Yes.
Yes? What did you think I was talking about? Racist? We don't talk about people that way. what I did there?
Yeah.
I'm feeling kind of goofy today. You can't stop me. I slept well.
Where do we write this?
I had lobsters for dinner, so I will buttered up. Would you call me? I'll fight you right now. I'll have you know with the thyroid condition. Big bones. All right, look. Look.
I have big bones.
Which of those is more diverse? School A or School B?
Wrong. School A. Trick question.
How many of you say School A? How many of you say School B? How many of you say trick question? It's School B. They have the same number of desk color species. Now, desk color doesn't make them different. Desk species, you realize. Races are not species of desk colors. But anyway, they have the same number of desk color races. One of them is even species evenness. One of them has what we call species dominance. Their richness is equal, 4 and 4. But more even, more dominated. And BT dubs, those are vocab terms in the assignment we're going to talk about today, so don't ask me about those because I have to use them. Anybody have questions about richness, evenness, and dominance?
So richness is
Number.
number.
Okay. For my easy demonstration with 4 different desk races at a school. Are you just trying to figure out what I'm talking about with desk?
Yeah, where do you want us to write this?
I don't care where you write this.
It's like on the back.
I'd like you to write it on your left forearm.
Don't do that. You're on.
On the bottom. Yeah, right there. Yeah. Uh-huh. Nope. Shut the bathroom. New son lost your tacos. All right. All right. In this example about the desks, it's actually really easy to compare the numbers because we're down to 4 and 4. It gets a little more complicated when you're trying to compare ecosystems because ecosystems have tremendous numbers of species and it's impossible to compare any 2 ecosystems because no 2 ecosystems would have the exact same number of species. And so in order to compare relative diversities across a map, some mathematician / science nerd figured out this simple equation. And I know that for some of you this looks intimidatingly complex, but I swear to you it's actually very, very simple. And the symbols you don't understand are probably very, very approachable, so don't freak out. I'll show you what this means. We got it. No need to worry. I'll walk you through this. On Thursday, you got to practice this for homework before you show up. So you'll need to do your lab prep and do this at home twice. Because then when you show up on Thursday, you're going to do it again with a real data set. Now, in high school, we have trained you to do math by copying off the smart girl or the smart boy. And I know that that would work for the homework, but that's a bad strategy because on Thursday you're still going to be on the spot to do this. I'm warning you in advance. The good news is it's actually very, very, very doable for all of you. I know you have the skills. All it takes is a calculator, some counting, and a pencil. That's it. It's just counting, I swear. So, first, please look up. On the Species Diversity Lab, you will need the equation with the variables. You don't really need the materials. And you'll need the procedure. Please look at procedure step number 1 where the hole punch is. It says, and I quote, prepare 3 in bold data tables. 1 of table 1 and 2 of table 2. Check this out. Flip the page. You love me because I gave you sample data tables so you have no excuses. And then look at the bottom of those data tables. It says pre-lab questions. Do this before class in bold, like really before class because it takes a lot of time. And then, could somebody please tell me which figure you will need to do your assignment? Which one? 7.2. You might be happy to know that 7.2 is awesome, but not actually the right thing. That's 7.2.
Beautiful. Is that environmental science?
I guess. First of all, the diversity of this diagram is 0. Second of all, yes, it is a unicorn, so I'm kind of glad that I've called your attention to this figure in your book. You might have otherwise missed it. But third of all, you'll want to fix the typo. It's actually not 7.2. My B-dog.
You have different.
It is 7.5,
Good.
which is not nearly as cool.
It's pretty cool. It looks like a bunch of acid tablets. You would see someone giving you that at a rave. Hey, tell me if that's not accurate.
It is accurate.
Yeah, it does.
All right. All right.
I can sell that page.
You gotta stop, dude. Now I wait for you. And then you go. And then I keep going. Which of these is more diverse? You can tell from across the room, just looking at it.
The bottom one.
The bottom. Right. But remember that in the real world with real ecosystems, you don't get to say, oh, that one, because it's really hard to tell because it's a lot of data. And so there's an equation for figuring this out. You can calculate and give these a number. And you'll have to practice on these, which are actually pretty simple. Before on Thursday, I gave you your cut of
I don't like
that. So, I can help you. This may look confusing to some of you, but it's just the negative sum of this equation for all the species that you've counted. That's it.
Oh.
And this equation, which to some of you looks impossible, is just one number you calculate times another number you calculate using a calculator button thingy. And so I will get you all the way to here from this picture so that you're almost done with your homework. But we're going to have to go kind of quickly, and you'll want to know these steps. You be quiet over there. It's not all about you. Okay, yeah, water. All right, watch me. You may want to write these down. Step number 1 is to name your species. You can name them whatever you want. Their names are not mathematically relevant if it works for you.
And that's the Shannon Diversity Index.
That's right, bro. That's why it says SDI.
I don't know.
So look, step number 1 is to name your species. And if you want, you can just call them by their number, which is step number 2, the integer for that. So they're called species number 1, species number 2, species number 3. Just so that you are clear, please look up. Both the integer and the name are for you to keep them straight. That's to help you. If you want to write that down in your notes, go right on ahead. Steps number 1 and 2 are just for you to keep them straight. Wherever you see I equals 3, that just means the third species. That's not math. I didn't do anything neat. There's no cosine or cotangents involved. This is not based on pi. You don't need to memorize any long numbers. This I is not for imaginary. It's just the number of that. So the third species is I equals 3. Cool? I've given it an integer, which means I've given it a count, like a placement in a sequence of numbers, like first, second, third, fourth, fifth, and sixth, and so on. I happen to know that you have 10 species in this diagram, but that's not exactly relevant to you, because this Thursday, you're going to have 1 quadrillion species. That's a scientific number. Now, can somebody please look on the front and help me decipher the meaning of the little n? Because I'm not very good at math. I don't have a math brain. I'm not the right type of person. There's something wrong with me. What does little n mean? Wait, what does that mean? Is that like some Einsteinian relativistic thing?
Yep.
The number of individuals of the species? What do you mean species I?
How many?
Which species is I?
do you have?
All.
Eyeball species? The species of meat? Kids are funny when they yawn.
Individual.
All species.
Number of the amount of individuals and species you choose.
The number of individuals in the species you choose. Yeah, you must be really good at math brain, right? So, what is my first n? N1.
The number of elephants.
Is the number of elephants, which happens to be 82. Don't waste your time. I already counted them.
Oh.
You will do this twice. One for the top. Stop it. One for the bottom. Because when you start yawning, then I have to yawn.
I can see your eyes. Drink some coffee next time. All right, look. N2 is the number of the second rhinos. 2 rhinos. N3 is the number of species number 3, which is hippo. So how many hippos? 2 hippos. They're hungry hippos. How many lions do we have? Well, that is our N4. I'll pick you up, I'll throw you over the fence. Keep going. 2 individuals of species number 5, which is the gazelle. Does everybody understand that in step number 3 we just count the individuals in each species? You just fill that into the table. Step number 4 is figuring out the big N. Whoa! Capital, not lowercase.
That must be something different. Because you had to press the shift key. So what does that mean? What is the big N? Ooh, total number of all species. You could count, but trust me, it's 100.
I don't know.
That's just for this data set. On Thursday, it would be like a quadrillion.
That's a scientific number. That's step 4.
That is step 4. You can tell because it has a 4 circled right next to it. Now what is PI? Like Magnum PI.
Relative abundance.
Relative abundance of species. What does that mean?
NI over N.
The what?
NI over N.
NI over N? Whoa, bro, that was way too many letters.
It's like 82 divided by
Percentage of that species within the population. How the heck would I figure that out? I'm not a math brain person.
N.
I'm a lobster brain person. In my head right now, there's all this buttery lobster.
Stop saying buttery lobster.
Isn't it just 82% and 2%, 2%?
That's right, but Math Genius over here is making everybody else feel inferior. So Math Genius, how do we figure that out?
82 divided by
Total number of species.
Watch me, everybody. The first P is little n over big N, which in this case is 82 over 100, which is 0.82. But in this case, little n over big N will be 2 over 100 will equal 0.02. And I could keep doing that over and over again, but you may notice that the numbers have changed. And so on.
Is there only 9 species? Or
Yeah, 82 plus 2 plus 2 plus 2 plus 2. Because he only needed 5 of the
And did he put in the,
Oh.
God. There's also a
I
monkey.
was just a little
There's also a monkey. There's also a monkey.
That's one.
All right. That's 2 monkeys.
Oh, really? Oh, yeah, there is.
So now, kids, step number 6 is the one that will blow your mind. So get ready. What is natural log?
A button on the calculator. LN.
It's a button on your calculator. Who cares what it means? Check it out.
Explain natural log.
Check it out. The buttons are shaped like that, and one of them will have one of these and one of those on it. And then you're good to go. That's the button you press first. I know.
It's going to get so confusing with eyes and the natural logs.
Allow me to demonstrate. You would press the LN button, then the decimal button, then the 8 button, then the 2 button, then the equal button, and then look at the screen and it'll give you the number. You don't have to know math.
How do you read them?
Good thing he's buttered up on lobster.
So this will be like a negative 0.198. And this will be a negative 0.07. What is that? No, it's a bigger number. 0.69?
That's
What is it?
Negative 3.9.
2.9? Okay. Now watch. Who cares? Use your calculator. I don't know. Dude, use your iPhone. I know you have an iPhone.
There's no
Yeah.
No way. No, no.
Use anybody else's iPhone. They all have one too. Now look. Pi times ln of pi just means this number times that number equals this answer.
Oh, that was a really good check mark.
Yeah, I love
Yeah, I was,
Oh, nice one.
You should take a picture
Well
of
done.
that. No, seriously, don't.
Okay, so what is that?
And then, after you have checked off all these, then step number 8 will be to add them all together, and that'll give you a negative number. You get rid of the negative number, see? And that'll give you your Shannon diversity index, which for no apparent reason is the variable is h. All the PILN PIs. So it is this total for all the species. Everybody stop. Everybody stop. Thank you. Please just answer the questions so that I can see how everybody's doing. Do you understand how to calculate P, which is the percentage or relative abundance for each of the species, by dividing the number of that species over the total number of individuals? Then, do you know that ln is a button on your calculator? So if you press that button and that number, you'll get column number 6. Is this cool? You can do that? You can press ln times these numbers that you've calculated. Now, please look up. You would multiply column number 5 times column number 6, and that will give you the P ln P, which is column number 7. Now please look up, because I'm almost done, but I'm not done yet. Once you have those for each of the species, then you total them all, and that is your Shannon diversity index. Watch, 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 watch. I will explain what the math means. Watch. You guys know you're going to add up everything in this column for all the species? That's what this means. The sum of P times ln of P, where P is little n divided by big N. For all of the species that you have, starting from the first one. Everybody who speaks math is like, well, yeah, I know, we just saw that like 20 minutes ago. But for everybody who has been miseducated to believe you're not good at math, there's nothing special. You just break it down into little pieces, and I did. And I even numbered the steps for you. So if you've chosen not to write those down, that's on you. But I'll need to do it one more time. Step number 1, you name your species. And step number 2, you number them. Those are just to help you keep them organized. Step number 3, you count the individuals in each species. You know, individuals in, each species. Like 97 white desks, or 25 brown desks. Those are the numbers of individuals in each of those species. Then step number 5, you'll divide that by the sum of all those individuals, the big N. Everybody can do that. I have faith in you. Then you use the ln button times that number for column number 6, and then you multiply both of them for column number 7, and then you add them all up and take off the negative in step number 8. Question? Gil, you had your hand up a second ago. I saw it.
Yeah, and it's never negative.
Oh, cool, bro. Remember that whenever you do a natural log of a decimal, you always get a negative sign. Maybe you do that. And so when you do the, these are always going to be negatives no matter what. It's built into the math. It's unavoidable that a natural log of a decimal will always give you a negative. So any population, anyone on the planet, no matter what you're talking about, desks at a high school or whatever, you'll always get a negative number, but it's an artificial number. It's called an index, where we assign a number to describe something, and indexes are not negative. So this is written in so that you'll be able to erase that negative. You can also just say absolute value, and that would work as well. Can I help anybody else?
Yeah.
Collector?
Are we getting the variables in class? Like during class?
Which variable?
Like you want us to set up the table, but the actual animals and numbers is going to be in class, right?
Remember this thing?
Right. Okay.
Anybody else?
What's a standard Shannon diversity index for the normal ecosystem?
They vary really greatly. In some ecosystems, you have tremendously dominant species. So, like trees in Tuolumne Meadows or Yosemite National Park, almost every single tree is a lodgepole pine. So that would have a very low Shannon diversity index. And a few trees in Yosemite Valley are very high because they're very evenly distributed among many species. In Belize, the numbers get astronomical. If you go to Indonesia, you get the world's highest Shannon diversity indices. Anybody else? I'm ready to move on. You would need to ask me your questions now, or be embarrassed and mocked on Thursday.
So H is just STI.
Yeah, exactly. H is just the variable which has been assigned to the Shannon diversity index, and I'd be really curious to find out how, but I don't know why it's H.
And you always take away the negative.
You do always take away the negative, because no matter what, when you take a natural log of a decimal, you'll have negatives. And it's a man-made number. It's a way that we use numbers to describe reality. It's an index. So you have to get rid of the negatives, because there's no point in having negative indices.
So you get rid of all of the negatives on that.
Right, or you take the absolute value of the sum. Either way you want to do that. On the top one, yeah. Anybody else? Yeah, I think so. All right. Oh, yep. Sorry.
You don't actually have to write off the whole like table for the pre-lab questions.
Actually, you do. I cry for you.
Yeah.
No, I don't.
We have such hard lives.
I know. Yeah, exactly. That does suck. Your first world problems are breaking my heart. Okay. Now, students. Vocab on assignment 5.2. Anyone? Anyone? Bueller?
Oh, there's that kind of thing.
What's that?
Oh, there's that.
Ow.
Careful. You want the rest of it? It's too far away.
All right, here we go. I've been asked, I'm going to start talking. You'll miss out. An indicator species is a naturally occurring species which tells you about the health of the environment. It indicates whether your environment is healthy or not. So like frogs indicate water quality. You should know that on the college board exam, they said that the canary in the coal mine is not an acceptable indicator species because it's not naturally occurring.
It indicates what?
I'm sorry. Next question. An umbrella species is one whose protection extends to other species.
when you like do human protection of that?
Yeah, so when you protect a condor, that's really helpful to frogs and lizards and snakes in the same area. So by protecting the loggerhead turtle, you've actually lowered bycatch throughout the fishery. Yes?
The flagship.
A flagship species is one that you think of first when you think about a certain topic. Yeah, so a flagship, you know, like when your country was going to be invaded and they were going to take all your gold and spices, the first thing you would see was the big old flagship, the one in the front that had a big old flag. So everybody on the coast could go, oh no, here comes Spain. The flagship, the one you see first. And so watch, I'll show you that all of you know a flagship. What is the animal that you think of first when I say climate change?
Polar bear.
Polar bear.
Oh.
That's why I'm glad you're not talking. The polar bear is the flagship for climate change. And that's what it means, the one you think of first.
How about air pollution?
Are we doing?
Wait, so it's the species you were looking first.
For a topic, yeah, it's the one that represents a topic. So like panda bears represent wildlife because there was this really powerful World Wildlife Fund in the 80s that really branded the panda bear. And for environmental protection, most people think of the whale because of Greenpeace and their very popular campaign to save the whales in the 70s. So now that climate change, the first species we listed was the polar bear. It's the flagship for climate change.
So an air flagship species.
Yeah.
I'm kind of fuzzy on genetic bottlenecks.
That's fine. The genetic bottleneck is an event which narrows genetic diversity. For example, I don't want to get into the mechanics of this, but if I were to choose 3 people at random in this classroom, your descendants would have far less genetic diversity than the descendants of this entire classroom. I'm sure you understand. I don't want to get into the mechanics, but in 10 generations, if all 30 of you were part of a breeding pool, you would have some redhead genes and some blonde and some curly and some straight and some black and some curly and some blue eyes and some brown eyes and maybe some green eyes. Got any green eyes around here? I don't know, whatever. You would have quite a bit of genetic diversity. But if I were to randomly pick just 3 of you, those 3 might not include someone with curly hair or Holroyd with the red hair. And so we could gradually reduce genetic diversity, and you realize that your descendants are not going to spontaneously recreate those traits. They're just lost from the gene pool. So check this out. Broad genetic diversity, bottleneck event, narrow diversity thereafter. The bottleneck is an event which lowers genetic diversity for the descendants thereafter.
Like an example would be just.
Yeah, like hunting or a big chunk of habitat blowing up with a meteor strike or whatever. It literally means you've lost individuals and you have less diversity left. First and second.
Does the name have anything to do with bottleneck dolphins, or is it just the
It's the shape.
narrowing? Okay.
Yes.
So the event is human cause or natural disaster?
It can be natural, yes. It does not need to be caused by humans. Anybody else? Yes.
So is genetic risk similar in a way? Or?
It is a type of genetic risk. Because if you have lost genetic diversity, now you're at risk of extinction because this is not enough diversity to go with. Next. Vocab. Okay, so I want to talk about study goal number 23, because I know a lot of you have been introduced to evolution in your educational career. And I know a lot of you have been taught evolution by a very disparate population of teachers. And you may have been mistaught evolution by people who have a vested interest in your not knowing. There's a really critical thing that I want to differentiate about natural selection and evolution. Evolution by natural selection, key terminology, is circumstantial, not intentional. There is no intent. It is the outcome of circumstance. It's not necessarily arbitrary, and it's not blind chance. But it is just sort of what happens. It's what you get. There's this really toxic misconception. The idea that evolution is the pursuit of perfection, or that it is improvement, which is not accurate. That's wrong. Evolution is not improvement. There's nobody who decides what's good or bad and whether that's the way you want to be or not. There's a very simple thing that I fear is lost, and that's the circumstance of evolution. Remember, given existing variation and a shortage of resource, some will have more babies than others. That's evolution. So given existing variation and competition over resources, some will have more babies than others. For example, do you know why there is no gene for giving away all your food? Because the poor schmuck who had those genes starved and didn't have any babies. That gene will never happen at all, ever, because that schmuck ain't going to have no babies, and that'll be the end of that gene. It would be nice to give away your food. Some of us could afford to give away your food. But genetically, that's never going to happen because that gene will disappear because the guy that gives away all his food doesn't have no babies. And that might be the best way for you to remember what evolution is and is not. It's not about what's better. It's not about improvement. We are not more evolved than anything else. Do you guys realize that all life is exactly the same, evolved? We are all equally evolved because we are all equally far away from the very first life on Earth. Some of us have adapted for one niche, some of us have adapted for a different niche, but that's just the circumstances of the variation that existed and the resources that were limited. That's it. People always ask me, are humans still evolving? And the answer is, of course, like everything else. But that doesn't necessarily mean we're getting better. I'll give you a perfect example. 300 to 500 years ago, this Jose would have gone extinct really early. This Jose can't see the floor. So this Jose would have starved, could not have seen the giraffe, let alone hit it with a spear. This Jose would probably have died tripping over a log or tripping over a rock or falling off the cliff, because this Jose has worthless blind guy genes. I am lion food. But hooray, we are evolving.
Are you super cool?
Because in this modern day and age, Jose can cough up a few $100, get some dope lokes, and now I can survive to reproductive age. And supposedly, those are my children. And lucky them, they probably got my lion food genes. So you know how humanity is evolving today? We're probably getting blinder, weaker, because strength doesn't necessarily decide how many babies you have. We're probably getting less intelligent, because you don't need to be smart to have a bunch of babies. You just got to be smart enough to feed them. And nowadays, that doesn't have to be that smart. So you know, we are evolving to be weaker, blinder, and dumber. Probably as a species. Think about it. Who has the most babies? I don't mean to say that dumb people are poor. I heard two different people say two grossly, unbelievably racist and disgusting things. But remember that who has the most children, is not about the most fitness anymore. And so yes, we are evolving. That's where we're going. Not improving. We're not the top of any ladder. We're just one line that will dead end someday.
Wouldn't the human population slowly be getting more attractive?
No. We've always been equally attractive because we've bred.
But like, wouldn't the more attractive people get more mates and then thus produce more babies?
But that's the whole point. There's always going to be the same diversity and the same diversity of choices.